My name is Dr. Esther Trufan, and in this experiment, I'm going to demonstrate the reaction between nickel to chloride hexahydrate and concentrated ammonia to produce hexamminenickel to chloride. So for this experiment, we need quite a bit of equipment. Our main chemicals are nickel to chloride hexahydrate, concentrated ammonia, ethanol, and deionized water. For each chemical, I will need a secondary container, except the deionized water. And for each one, because I will be measuring their volumes, I am using a 10 milliliter graduated cylinder. If you're working with only one graduated cylinder, make sure that you rinse it with water thoroughly and then dry it between measurements. I will need to know the exact mass of my nickel chloride hexahydrate. So I will need a scale and a weighing boat. And when I make my final solution that will release the precipitate that is the hexamminenickel chloride, I will need to do a filtration. For that, I will need everything that is required for a Buchner filtration: a Buchner flask, a Buchner funnel, filter paper, and a rubber hose to attach to a vacuum line. For my final measurement, I will also need to collect the product, and the product will need to be weighed so that we can have an opportunity to collect the actual yield during the experiment and then determine the percent yield of the process at home. So I will need an additional weighing boat for the end, and to contain my material, I will place it on a watch glass. If I need help stabilizing the amount of volume that is transferred from one container to the next, or if I'm working with small amounts and my hand isn't quite steady, it is best to prepare a couple pipettes on the side. And here I have one. To measure out my nickel chloride hexahydrate, I will need a spatula. And now we can get started. The first thing that we will need is a beaker that will have 3 test tubes in it. And then all these test tubes will move either into a hot water bath or an ice water bath, which I prepared in the back of my fume hood. The reason why I'm working in the fume hood for this experiment is because I am using concentrated ammonia, and that is very hazardous to work with, especially if our fume hood is not working. So let's get started. First thing that we're going to do is measure out 1 gram of nickel chloride hexahydrate. For this part of the experiment, we're going to turn on our scale. And when it says 0.00, we place a weighing boat on top, and then we hit tare so that it goes back to 0.00. We transfer a small amount of the nickel to chloride hexahydrate in a secondary container. If it's hard to do that, we can always scrape it a little bit with a spatula and nudge it out. From there, we transfer 1 gram into our weighing boat. If it's a little too much, we will extract it and transfer it back into the secondary container, which will then be disposed of as waste. We take our weighing boat with the nickel chloride hexahydrate in it and transfer it into a test tube. Once done, we are finished with the scale for now, and we can set it aside. We're also done with the nickel chloride hexahydrate, and we can set it aside. Next, we're going to measure out 1 milliliter of deionized water. This is a very small amount, so I will transfer it using a pipette. It is important that we don't add more than 1 milliliter, and I have 0.98 milliliters here. It's not a lot of water, so we're going to have a very small amount of solution. It is unlikely that it will dissolve all by itself, and this is the part where we bring in our hot water bath, and we will use it for just a little bit. With that, we're done with our water. Next, we measure out 5 milliliters of ethanol, and we're going to put it in our ice water bath. This doesn't have to be exact, and it can be above 5 milliliters. I have 5.59 milliliters, which I will first transfer inside a test tube, and then inside the ice bath. In the meantime, you'll notice that our nickel chloride dissolved in that tiny amount of water, and now we have a solution. We can put it back inside the beaker and hope that it will stay dissolved. If it precipitates any of the nickel chloride, we can always put it back in the hot bath. Next, since we're done with the ethanol, we're going to set it aside and measure out the ammonia. Of the ammonia, we're going to first measure out approximately 4 milliliters. You can pour out from the original container or from a secondary container, depending on how steady your hands are. It is always best to use a secondary container. It is a little bit more than 4 milliliters. It is 4.93 milliliters. I will pour it into a test tube and then place it in the ice bath. Next, I am also going to measure out approximately 6 to 6.5 milliliters of concentrated ammonia. I have 6.20 milliliters of concentrated ammonia. And this is where we are done with the concentrated ammonia solution, and we can set it aside. Let's begin the experiment. We take our test tube that contains our dissolved nickel 2 chloride. We're going to add to it the 6 milliliters of concentrated ammonia solution. And when the addition is complete, we're going to shake it well and place it in the ice bath for at least 5 to 10 minutes. In the course of it sitting in the ice bath, it will precipitate the product, which should be the purple lavender colored hexamminenickel 2 chloride. While the product is precipitating, we can prepare for the Buchner filtration that follows right after. First, we connect the rubber hose to the vacuum line. Then we make sure that there is a filter paper that fits inside our funnel and that we have a clean and dry Buchner flask. By now, we should see some purple solid depositing on the bottom of our test tube. Once precipitation is complete, we can move on to filtration. So we're going to take our test tube, transfer a small amount of the solution that is on top onto the filter paper. And if we move it around, it should get all the surface of the filter paper wet. Now we can connect to the vacuum line and make sure that there is a solid seal, and everything that we put on top of the filter paper will have to go through the filter paper, and no particle larger than the pore size of the paper will go through. And now we have a good seal, and we're ready to transfer all our solution on top while we're applying the vacuum to it. We still have a little bit of purple solid left over, and this is where our transfers and washes begin. First, I will disconnect from the vacuum line because I will need both hands, and I can't let go of the Buchner flask while it's connected to the line. In the first step, I'm going to take my ammonia. I can check for my ammonia. I will add approximately half of my original 4 milliliters of ammonia into my test tube. I will swirl it really well. And after I connect to the vacuum line, I will transfer it very quickly onto the Buchner funnel. I will add the remainder of my concentrated ammonia solution. And then I can discard of the test tube. The last step is to make sure that we rinse our precipitate really well with ethanol, and that will ensure that the residue from the water and the concentrated ammonia solutions are removed. So I will disconnect, add approximately half of my ethanol to it, and then reconnect to the vacuum line to suction it off. We swirl it around a little bit to have good contact between the solid and the ethanol, and then we suction it off. And then we do this again, and this way we can dry our solid much more efficiently. Now we simply apply suction filtration until the paper looks dry and the solid seems powdery. When it appears powdery, we can take a spatula, scrape at it, and if it lets go easily and it is more a powder than mud, then we can consider our process, our filtration and drying complete. In the next part of the process, we're going to remove the filter paper from the funnel and transfer all the solid with the filter paper on a watch glass, and from there we will record the final mass of the product. If there is solid stuck to the funnel, we need to scrape that off and transfer it onto the watch glass. When our transfer is complete, or as complete as we can get it, we will acknowledge that no transfer is 100% effective, and we move on to the next step. For the final step of our process, we're going to bring back our scale. Turn it on. Tare it. Bring in a clean and dry weighing boat. Tare it. And then transfer all the solid from the watch glass and the filter paper onto the weighing boat. We can gently scrape the filter paper, but not too hard, because while we want to extract as much of the powder as possible from these pores, we definitely don't want to scrape off any of the cellulose fibers from the filter paper. Once we're done, the contaminated filter paper goes in the solid waste container. The final mass of my recovered product is 0.35 grams. And this goes to show that not every complex formation reaction goes to 100% yield. Some of them have significantly lower than that. And this may be one of those instances. The 0.35 grams of the hexamminenickel to chloride is your actual yield for the reaction. Knowing the original amount of the nickel chloride hexahydrate you started with, you can easily calculate the theoretical yield, and from the combination of the two, you will be able to determine the percent yield of this complex formation reaction.